Okay, good afternoon. So in the last lecture, we have started the unit number 2, and the point we have started the admixtures we have to add in the concrete. So various types of admixtures we have seen in the last lecture. So we have covered the 3 types of admixture, that is plasticizer, super plasticizer, and retarder. So the various types of admixtures are we are using for the different purpose, and the different purpose are we for the different purpose we are using. That purpose are to maintain the workability, to increase the strength of the concrete, and to maintain the durability. For this all purpose we are using this particular admixtures. So next type of admixtures which we are using in the concrete, that is the accelerator. So what purpose we are using the accelerator, and what is the need for the use of the accelerator, for what is the mechanism behind the adding the accelerator for into the concrete, so that we will see. So the need of the adding the admixture into the concrete is the accelerating admixture are added to concrete to increase the rate of early strain development in the concrete. For what purpose we are adding accelerating admixture? To increase the rate of early strength development in concrete. So as we are using the cements of various grades, so the various grades of cements we are using for the in the concrete, and that cements are the setting time of cement is not more than 30-minute initial setting time, and not less than 30 minutes, and not more than 600 final setting time. But similar to this, we have, if sometimes we are we are doing concrete in seawater, or in the underwater construction we are doing, at that time yeah, it is necessary to set the concrete in early stage. So for that purpose we are adding this accelerating admixture to the increase the rate of early strength in the development of the concrete. So so it permits, this accelerating admixture is a permit earlier removal of formwork. So what we can do, if we add the accelerating admixture, so we can permit early removal of formwork. So generally the de-shuttering of formwork is as per the some of the IS, there are some days are required to de-shuttering. If we are de-shuttering of beam bottom, if we are de-shuttering of slab bottom, so there are some standard days we have provided in our IS code. So not more less than 40 days we are removing the formwork of slab, or not more than 21 days, not less than 21 days we are removing the formwork. But if we use the accelerating admixtures, we can permit to removal of formwork in early days. So for that purpose, why? Because the accelerating admixtures we are using to get the early strength. So increase the early strength, we are for getting the early strength, we are using accelerating admixture. So if we get the strength of the concrete in early days, then we can remove the formwork also in early it means not as per the specified days. So then the need of the accelerating admixture is to reduce the required period of curing. So as per the Indian standard, so maximum 28 days we have to cure. Minimum 28 days we have to provide the water to the whatever concrete element we have casted. For that purpose we have to provide the water minimum 28 days, maximum you can provide. But that 28 days curing period is a one month of period. But if we add the accelerating admixture, then we can reduce the required period of the curing also. Then advance the time that structure can be placed in service. So when any structure is in the service, it means existing structure is there, and we have to repair some for that structure also, and we have to again get the structure into the use. So then or in service, at that time we are whatever concreting we are doing, in that concrete we have to add the accelerating admixtures, then and then we will increase the strength in early days, and we can use the that existing component or structure in service in early days. So that purpose again we are adding the accelerating admixtures for the early to get the early strength. Again, we can compensate for the retarding effect of the low temperature during cold weather concreting. So we can compensate the retarding effect of the low temperature also during the cold weather concreting also. And in that also this types of admixtures we are adding to for the emergency repair work, if any emergency repair work is there. So as I told you, some of the bridges are there, some of the where the traffics are there, but that traffic we cannot uh, to we can early we have to release that traffic from that particular road or bridge. So at that purpose, if we have to repair the work on a particular component of the RCC component, at that time we can use this accelerating admixture into the concrete, so that we can the early strength we will get, and the emergency repair of that work will be takes place. So these such are the needs of the accelerating admixtures, and that needs are very that needs are specifics if we use the admixtures, accelerating admixtures. Then the materials used in the accelerating admixtures are the calcium chloride in a popular accelerator. So if we are using the accelerator admixture, so the whatever the popular accelerator we are using in the market or in the concrete nowadays, in that the chloride calcium chloride is one of the material we are using. Actually the accelerator are actually the admixtures are the chemicals. So that chemicals which we are using that for the different purpose, early setting, or if retarder we are using when we have to increase the setting time of the concrete. So some of the admixtures we are using for the early getting the early setting, and some of the admixtures we are using for the delay of setting time. So it means if you see, so admixtures we are using that delaying setting time and early setting time. So for both the purpose we have admixtures that are the nothing but the chemicals, and that chemicals in the accelerator we are using the calcium chloride. So then soluble carbonates and silicate, this fusilicates also we are using for the getting the early strength in early days. Then again organic compound as trithylenolamine also we are using, and that trithylenolamine is also one of the major material or major chemicals that we are using in the accelerator, which is which cause the early strength of the concrete. So then the mechanism of for the accelerator admixture is the lower the temperature at which freezing will take place. The temperature will be the lowers the temperature at which the freezing will takes place. At that time the freezing will be there, the temperature will be lower. It means if we add the water into the cement, the harden reaction, heat of hydration will be takes place, and that hydration process will be are freezed in the म्हणजे आपण म्हणतो की हीट ऑफ हायड्रेशन होत असताना हीट सिमेंट मधून बाहेर पडत असते आणि त्या बाहेर पडत असते जोपर्यंत हीट पूर्णपणे सिमेंट मधली बाहेर पडत नाही तोपर्यंत काय होत असते पूर्णपणे तुमचं कॉन्क्रीट सेट होत नाही म्हणजे जर आपण ऍक्सेलरेटेड ऍड केलं तर टेम्परेचर हे लो केलं जातं सिमेंटचं आणि फ्रीजिंग म्हणजेच जी काही कंडिशन आहे कुलिंगची कंडिशन ती अर्ली स्टेज मध्ये होते सो दॅट इज द मेकॅनिझम ऑफ दॅट ऍक्सेलेटेड क्युरिंग accelerator add mixture. So then the keep mixture warm by generating the heat by chemical action, as I told. So heat, whatever heat in the cement, that heat will be generated or heat will be released early due to the chemical action happens with the cement and for so the strength heat will if heat release early due to the heat of hydration process and addition of the accelerating admixture, then your setting time will be reduces and the early strength concrete you will get. Then resistance against freezing is increased and strength gain increased. So the resistance against freezing is also increased. So heat of hydration process is a very slow process. If we add the water into the cement, the heat of hydration process is running. So if the heat of hydration process is going down, at that time what happen? If we provide the water, means curing period is going down. At that time your heat is releasing. But if we add the accelerating admixture in the early stage, the freezing process is increased. It means cool व्हायची process ही लवकर start होते जेव्हा आपण accelerated admixture add करतो. And again the other parameter is the strength. So strength again get increased in early time. So these are the mechanism which we are which will get during the process of if we add the accelerating admixture into the concrete. So what results are to be observed when the accelerating curing so accelerating admixtures we are using in the concrete, that the results are the increasing the slum up to the slum in the constant water cement ratio up to the 300%. So that is very good advantage of this accelerated admixture is increasing slum in constant water cement ratio up to 300%. So 100% is a good, but up to 300% if we increase this slum, it means the quality of concrete will be maintained and we will get the strength of the concrete also. So that is the result also. Then shortening mold time also. So mold time, whatever shape we have given to the concrete. So we are casting the column, we are casting the beam, we are casting the slab. It means we have given shape to the concrete. So that mold, column molds, beam mold, that will be the shortening. It means early it will set early that mold size will get. So high and high initial and ultimate strength. So initially high strength will be there and ultimate strength is also high. Why? Because the accelerated admixtures we are using, that is admixtures we are using for the strength which we have to get early. लवकर स्ट्रेंथ मिळण्यासाठी आपण ऍक्सिलरेटेड ऍडमिक्चर यूज करतोय आणि ते ऍडमिक्चर्स ऍड केल्यामुळे कॉन्क्रीटला इनिशियली आणि अल्टिमेट फायनली both these strengths will be high and reducing the risk of stress cracks. Also, due to the some stress or distress cracks noticed, or it will it we can reduce. म्हणजे क्रॅक्स वगैरे जे काय अर्ली कधी पाहायला मिळतात जर पीपीसी सिमेंट आपण यूज केलं तर सरफेस वरती इनिशियल स्टेज मध्ये आपल्याला सेटिंग टाइम लवकर नसते, so that the cracks will be shown on the surface of the slab or beam if PPC cement we will use, because the PPC cement the strength early strength not getting. So if we add the in such case if we add the accelerator, then early strength we will get, so reducing this risk of the stress cracks also. So this is the one of the graphs they have given as per the doses of the accelerating admixtures, and the setting time is also shown here. So the setting time is in minute they have shown in the on the y-axis. If you see in on the x-axis the doses they have given in centimeter cube, the 50 100 150 200 up to 350 they have given, and on the y-axis the by the modified WCAD apparatus they have shown the setting time also. So that setting time in minute, so 150 minute 200 minute 250 minute 300 minute 350 and 400 minute they have shown. So now you can see here, so control 1, so the shape is here shown. The accelerated standard calcium chloride, then this accelerated NCA. So these are the doses they have given on the x-axis, and on the y-axis the setting time is there. So if you see 200 minute 250 minute 300 minute, so not more than 350 minute. So 350 minute means what? How much? How hours? So 60 120 60 minute means 1 hour, 120 means 2 hours, 180 means 3 hours, 240 means 4 hours, and 300 means 5 hours. So within 5 to 6 hours if you see the setting times less than 320 or 350, it means your concrete will set within 5 hours. Within 5 hours you will get the strength, more strength within the 5 hours. So this is the graph shown here for the all the types of materials or chemicals added into the that particular concrete. Are you getting? Early strength we will get. So early strength means within 5 hours we will get the strength 100% if we add the accelerated admixture. So this is the related the accelerated admixture. So next admixture is the air entraining admixture. So that air entraining admixtures, why we are using the air entraining admixtures? So this see we are learning here advanced concrete technology part. So generally we have we know the ingredients of concretes are cement, sand, aggregates, and water. These 4 are the main ingredients of water. But now only that is not sufficient. Why? Because depends upon the environmental condition. We require early setting of concrete. We have to provide the concrete in underwater construction. We have to delay the time of the setting. So various factors are there. So for that factors we have to add the admixtures, and that admixtures are what doing? That admixtures roles are playing very important roles. They are playing admixtures. So some of the admixtures are reducing the water. गरज जेवढी आहे तेवढेच पाणी ठेवलं जाईल, त्याच्यापेक्षा वॉटरचं रिडक्शन केलं जाईल, म्हणजे कमी प्रमाणात वॉटर वापरून जास्त प्रमाणात स्ट्रेंथ दिली जाते. सो that is the plasticizer also. Then if retarder is a delaying setting time, म्हणजे तुम्ही कॉन्क्रीट जर ट्रान्सपोर्ट करत असाल, प्लेसिंग टाइम तुमचा इन्क्रीज करायचा असेल, आरएमसी मधून कॉन्क्रीट जाणार असेल तर यू रिक्वायर्ड ट्रान्सपोर्टेशन टाइम, मोर ट्रान्सपोर्टेशन टाइम. सो फॉर दॅट अर्ली सेटिंग इज नॉट रिक्वायर्ड. म्हणजे लवकर सेट होऊन चालणार नाही. ज्यावेळी मिक्सर मधून तुमचं कॉन्क्रीट साईट वरून आरएमसी मधून साईट वर येते त्यावेळी रिटार्डर यूज करू शकतो आपण. देन ऍक्सेलरेटर, व्हेन वी आर युझिंग, we require the early strength. At that time we are using the accelerated admixtures. And the next admixtures that we are seeing here, air entraining agents. So for this air entraining agent, what need is required, why air entering we are using? So the ordinary concrete content about 2% entrapped air. The concrete आहे त्याच्यामध्ये 2% of entrapped air is there. But an air entraining admixture results in the millions of the tiny air bubbles in the concretes. What? Air entraining admixtures resulting the millions of tiny air bubbles in the concrete, and that increasing the air content up to the maximum at 8%. So generally 2% of air is available into the concrete. If we go for the mixed design, you will get, as in the IS code we have given, in IS code they have given the 2% of air is available into the concrete. If we make the concrete, so 2% air will be there. But if we add the air entraining admixture into the concrete, so the bubbles and that percentage of air is increases up to the 8%. So why we have to require increase that air? So increase the workability. If we increase the content of air, that is the maximum up to 8%, we can increase the workability of concrete. Then decreases the permeability and decrease the freeze-thaw damage also, and reduce the segregation. So the bubbles will be increases. So due to the bubble, your the segregation will be the reduced, and the increase in the workability of the concrete. Also, we can decrease the permeability of the concrete also by adding the air entraining agent. So what materials we are using into the concrete? So the materials are the, so generally these are the following materials we are using as a air entraining, making air entraining concrete. So natural wood resins. So natural wood resins we are using for making the air entraining agent. Then animal and vegetable fats and oils such as tallow, olive and oil, and their fatty acids such as stearic and oleic acid. So these such acids we are using into the concrete as a air entraining agent to increase the air percentage into the concrete, to decrease the permeability and increase the workability of the concrete. Again, the various wetting agents such as alkali salts or sulfate and sulfonated organic compounds are also we are increasing. Also, we are using. So these chemicals we are adding into the concretes. So this is the need to increase the air content into the concrete. So then the water soluble soap of the resin acids and animals and the vegetable fatty acids also is the need of the to increase the air entraining air into the concrete, that is up to the 8%. And so this is related to material. So this material we are using. And again, sodium salt of the petroleum sulfonic acid also we are using, and hydrogen peroxide and aluminum powder we are using to into the concrete as a air entraining agent. So these all the chemicals we are using as a air entraining agent into the concrete. So what mechanism is behind this, the using the air entraining agent, and how the mechanism is developed or formed while we are using this particular air entraining agent. So the mechanism behind this is the bubbles of entrained air act as a lubricant. So whatever bubbles we are increasing, into the concretes, that bubbles act as a lubricant. So between the aggregates and particles. So whatever cement particles are there, or sand particles are there, or coarse aggregate particles are there, in between the that bubbles act as a lubricant. So these tiny bubbles eliminate the large voids and allow water to penetrate and expand during the freezing. So that bubbles are eliminating the large voids, whatever voids are there, that eliminated, and allowing to penetrate the water into and the expand during the freezing process. So for that purpose, in this way the mechanism is developed during the if we add the air entraining agent into the concrete. So then so the factor affecting amounts of the air entraining. What are the factors which amounts of the air entrainment? So if you see here, the manufacturing of air entrained concrete is complicated by the fact of the amount of air and air entrainment in the mix is affected by the factors. That factors are the type and quality of the air entraining agents used. So whatever types of the air entrainment and the air entraining agents that we are using, so that factors affects on this particular. First point is the type and quantity. Then second factor is the water cement ratio of the mix. So whatever mix we are doing, for that purpose, whatever water cement ratio we have used, for that water cement ratio, is affecting the amount on the air maintaining agents. Then types and grading of the aggregates. So various types of two types of main aggregates we are using, that is fine and coarse aggregate. So grading of that aggregate is also affects the particular air training agent. Then mixing time, how much time you have mixed that particular concrete after adding the air entrainment. So that admixture we are adding and mixing for how much time. Then temperature. So what is the normal temperature? In generally 27 to 28 degree, we have to that temperature is required to make the concrete. But sometimes if you in our Maharashtra state, if you see in the summer season, the temperature is up to the 40 degree, 42 degree. So where is the possibility of the 27 degree temperature? 27 degree temperature असणार आहे का उन्हाळ्यामध्ये? And generally, so we are doing the that works in such summer days also. Why? Because in rainy season we cannot go for the civil engineering projects. So from the November, December to May, probability we are doing our construction works. So the temperature is a very, very important factor which affects on the amount of the air entrainment. Then types of cement, which type of cements we are using. There are various grades of cements and various types of cements also there. So which type of cement we are using, or either the ordinary Portland cement we are using, or either the pozzolana cements we are using. So various types of cements we are using. That again factor is depends on the for the amount of air entrainment. Then influence of compaction. So how you are compacting the concretes, that again influence is there, because air entrainment agent is what admixture what doing, because this is the reducing the permeability, decreasing the permeability, and increasing the workability. So if you the compaction process is a very important, which method you are using for the compaction, that is influence the your amount of air entrainment. And the admixtures other than air entraining agents also which you are using, that again that factor is also important. So the effect of air entraining on the properties of the concrete. So there are various properties of concrete: strength, workability, then durability. So such properties are very important if we add such admixtures into the concrete. If we add the air entrainment into the concrete, what effects काय होईल जर आपण अशा पद्धतीचं जर एअर एंट्रेनिंग जर आपण वापरलं कॉन्क्रीट मध्ये, की ज्याच्यामुळं एअर वॉइड्स तयार होतात आणि त्या एअर वॉइड्स काय करतात, ड्युरेबिलिटी इन्क्रीज करतात आणि परमेबिलिटी डिक्रीज करतात. मग कशासाठी वापरायचं, त्याचा इफेक्ट काय होतो? So the effect behind the this particular air entraining will affects directly the 3 pointers. So the increased resistance of freezing and throwing. So resistance to freezing. So as I told you, the temperature into the cement is there. So if the reaction of if we add the water into the cements, the water cement ratio, if we maintain the water cement ratio, then the when the reaction takes place between the water and cement, at that time the hydration process will be there. So at that time your temperature will be released and your cement will be setting, and it will be the cooling. So that the cooling process is nothing but here freezing, and to increase the resistance to freezing साठी जो काय resistance आहे तो increase केला जातो, and for thawing also. The improvement in the workability. So again the effect on the air entraining is to improvement of the in the workability. So workability of concrete is nothing but what? That flowing the concrete. So and the reduction in the strength. So these are the effects of air entrainment on the properties of concrete. So reduction of the strength is there, then improvement of workability is there, and the freezing, resistance to freezing. So these are the very important effects on the concrete. So then if the incidentally air entrainment will be also affects the properties of concrete in the other ways also. So that other ways are the reduce the tendencies segregation, then reduce the bleeding and lightens, then decrease the permeability, increase the resistance of chemical attack, permit reduction in the sand content, improve placeability and early finishing, then reduce the cement content, cost and heat of hydration, then reduce the unit weight of concrete also, then permit reduction of water content also, and reduce the alkali aggregate reaction also, and reduce the modulus of the elasticity also. So these all the parameters of the or properties of concretes we can reduce, decrease and permits or improves. So these all the parameters. So these all other properties of the concretes are also affects if we use the air entrainment agent as admixture into the concrete. So the resistance to freezing and throwing, it means what? So resistance to freezing into throwing is the greatest advantage derived from the use of the air entrained concrete is the high resistance of hardened concrete to scaling due to freezing and throwing. Again, it is found that the ordinary concrete is subjected to temperature below freezing point, and the water contained in the pore of the concrete that freezes. So the resistance to freezing and throwing is the one of the greater advantage of this adding the entraining agent is to use the air entrained concrete is to high resistance of the hardened concrete due to the freezing and throwing. So this is one of the effect. Then effect on the workability. If we add the air entraining agent, so what is the effect on the workability? So generally, the if we add the air entraining agent into the concrete, so the air entrainment of the air in fresh concrete by means of the air entraining agent improves the workability. So as I told you, the workability of concrete is improved if we add the air entrainment. It was seen that the place ability to air entrain concrete having 7.5 slum is superior, so that non-entrain having concrete is at 12.5 centimeter. See, if the concrete with the air entrain having the slum of 7.5 centimeter, and if the non-entrain concrete is there, then the slum will be the 12.5 centimeter. So this is the effect on the workability also. Then the effect of strength. What is the effect on strength? So the effect on strength is also one of the important properties of the concrete. So what effects will be there on the strength due to addition of the air entraining? So here, if you see, it can be generally stated that the air entrainment in the concrete reduces the compressive strength of the concrete. See, if we add the air entrainment admixture into the concrete, so the compressive strength of the concrete is reduces, and the process is applied for this particular. But when the process is applied for this concrete, the taking advantage and of the benefit occurred on the account of air entrainment, and due to this no loss of strength should be take place, and it is even possible that under certain circumstances a gain of the strength may be possible. So if we add the air entrainment admixture into the concrete, so it is possibility to loss of strength of concrete, and but even possible to that the gain of the strength may be possible during this addition of this air entrained concrete. So the next effect of this particular type of admixture is effect on segregation, bleeding, and latence. So if you see here, so effect of segregation and bleeding. So the segregation and bleeding of the concrete are different. Manifestation of the loss of homogeneity. So loss of homogeneity, it means what? So if we the homogeneity is nothing but the properly mix of all the materials without any voids or any gap into the particular concrete. But if we add the air entrainment admixtures, what will happen? So the air content will be the increases into the concrete, and if at that time the loss of homogeneity, म्हणजेच जी काय ऑल मटेरियलची होमोजेनिटी आहे ती रिड्यूस होते, लॉस होते. So the segregation usually implies separation of the coarse aggregate from the mortar. or separation of cement paste from the aggregate. So everybody or everyone as knows about the segregation. So segregation is nothing but the whatever cement water paste is there, that cement water paste is come outside from the aggregates, and the aggregates are separated and cement paste is separated. So that is the separation process. So these and that we are calling as a segregation. So that segregation process is usually happens due to loss of homogeneity, and that homogeneity is disturbed, or loss of homogeneity is due to the only and only if we add the air entering agent. Then the bleeding is heterogeneously flow of the mixing water with the within or its emergence to the flow from the fresh placed concrete. So what is bleeding? So again, bleeding is nothing but the flow of mixing of water within or its emergence. And usually the result of this sedimentation of the solid due to compaction and the self weight of the solid. So self weight of solid and compaction, this bleeding will take place, and the effect of this bleeding and segregation is also there if we add the air entering agent. Then next is the effect on the permeability of concrete. So the air entering of the air does appear to have much effect on the permeability of the concrete. So as we have discussed in the we are decreasing the permeability of concrete if we add the air entering agent into the concrete. So the air entering is of air does appear how much the effects on the permeability. So greater uniformity of concrete with entrained air due to its increased workability, modify pore structures of the air entrained concrete, reduction of water channel due to reduction of bleeding are some of the reasons for the improving the permeability. So generally the permeability is decreasing if we add this particular air entraining agent, but we can improve the permeability of concrete also for the some specific results also. So effect on sand, water and cement content. So whatever cement, sand and water we are adding into the concrete. So what is the effect of that air entering agent on the sand, water and cement that we will see here now. So generally the minute several air bubbles act as a fine aggregate. Okay, so the bubbles are forming if we add the air entering agent. So the bubbles are forming, and then bubbles are acting as a fine aggregate. The air bubbles are there, the bubbles are acting a fine aggregate. So that fine aggregates, and that enable the reduction of the fine aggregate. So the reduction of fine aggregate further enable to reduction of the water requirement with the impairing the workability and slump. So the reduction of water requirement without impairing the workability of some or slump. So this will have to consider the designing air entering mix. So the characteristics of this entrainment, there are some characteristics are there. So that characteristics of the air entrainment of the concrete that we have to consider while designing the mix design of the air entering agent. So this also affect on the sand particles also if we add the into the concrete. So what are the results if we add the air entrainment concrete into the air entrainment agent into the concrete, what will be the results? So results are the entrained air increases workability. So whatever bubbles are formed, that bubbles are increasing the workability of concrete, and that workability of concrete increases and the water cement ratio can be reduced. So the water cement ratio can be reduced if we use the this particular admixtures, and due to that the increasing the strength and durability also, and the wear resistance of the concrete. So that bubbles are acting as a lubricant. Bubbles are acting as a lubricant, so that the lubricant may plays an important role and resist the wear of these concrete aggregates and cement paste and that fine aggregates also. That wear resistance is there, and if we add this particular admixture, we can increase the strength and durability also. Also we can reduce the workability of water cement ratio, and we increase the workability. So here main parameters properties of concretes are workability, water cement ratio, strength, and durability. So all are maintained properly if we add the air agent into the concrete. So so here we will stop. So next type of admixture we will see in the next lecture, that is a pozzolanic material. That admixture we will see into the next lecture. So today we will stop here. So wait, I will take attendance and we will close today.